everyone, welcome back to the third part of the video. In this video, we will be solving part B1, which is for architecture candidates of GATE 2025 Architecture and Planning question paper. So as mentioned in our section 3, previously we have solved general aptitude and part A, which is common part for both architecture and planning candidates. In this section, we will be solving part B1, which is for architecture candidates. So now in this set, there are a total of 16 questions, out of which we have 7 questions which are 1 mark question, a mix of MCQ, MSQ and NAT, and then we'll be having 9 questions which are 2 mark questions, so giving a total of 25 marks. A similar format is also for part B2, which is planning candidates. It has a mix, again, both the sections have a mix of MCQ, MSQ and NAT questions. So let's start with question number 50, which is the first question for part B1. This question is taken from section B 1.1, History and Contemporary Architecture, especially from Indian Architecture, Mughal section. So talking broadly about the kind of syllabus and portion which is there for part B1, B1 has 3 major subcategories. First is B 1.1, which is History and Contemporary Architecture. Then you have B 1.2, which is your building construction and theory of structures. And then you have B 1.3, which is building services and sustainability. So these are the broad categories or broad sections which are there under section part B1. So let's start with the question number 50. Question number 50 is a 1 mark MCQ question. With reference to squinch adopted in dome construction, choose the correct option related to statements P and Q. So they have given 2 statements. Let's see those. Statement P, squinch is a structural element used to support the base of a circular or octagonal dome that surmounts a square hall. And Q is, squinch is a double layered dome comprising of an inner and outer layer of masonry. Okay, so let's understand what exactly is squinch in dome construction. So generally in as we study history of architecture, we have seen progressively in various civilizations, various empires like Byzantine Empire. Then we have seen different cathedrals. In India, we have seen Mughal architecture. And then we have also seen various Indo-Saracenic architecture as well as a lot of Victorian architecture, right? All of these styles and many more styles have dome as a special key architectural element or architectural feature. So generally what happens is there are 2 broad structural elements that would help transfer the load from a dome to the abutment or to the pier. So generally if you see, dome is circular or elliptical in nature, right? But it will be resting on say 4 columns on the side or a shear wall, which is square in plan, right? So generally what happens? There are 2 methods of load transfer. First is in this circular base, you start forming these large spanning arches, right? So this is your square column ka line and this is your dome, and these triangular curved portions are called as pendentives. The example being Hagia Sophia, right? Squinches, on the other hand, is a more simpler and effective method than pendentives. And in this method, we have the circular base and we have the square base, right? So the circular base actually rests on a further octagonal base. And this octagonal base, as you can see, is further corbelled from the inside. So if you see the inside, the dome will be resting on corbelled members. So this corbelling is called as squinch. When you see it in 3D, this corbelled, I would say this entire portion which is corbelled, which helps the load transfer from a circular dome to a square or an octagonal base, is called as squinch. We see squinches in lot of Mughal architecture, then a lot of late Jain architecture, and it is an important feature while studying Indian architecture. So, as we know, squinch is a structural element used to support base of a circular or octagonal dome that surmounts a square hall. So, this statement is definitely true. Q, squinch is a double layered dome comprising of an inner and outer layer of masonry. So, this starting statement, squinch is a double layer dome, is itself wrong because it is not a dome but it is a structural element which is helping in load transfer from a circular base to your rectangular or octagonal square column base, column grid, or shear walls. So this first statement itself is wrong, so we'll consider Q as wrong. Now let's see the option. Both P and Q are true. No, P is Q but Q is false, so this has to be the correct option. Let's move on to the next question. Question number 51. It is from Building Services and Sustainability, which is section 1.3 from HVAC systems. In heating, ventilation, and air conditioning, that is HVAC systems, HVAC dampers are essentially dash. So, what is the role of HVAC dampers in HVAC systems? So, generally, before going to the options, if you see this diagram, HVAC dampers are located between your distribution zone and your conveyance zone. So your conveyance is your ducts. So these are like walls that are keeping in check the amount of air that is flowing from your distribution system to your duct system or your conveyance system, right? So what is happening first, if you see dampers, they play a key role in HVAC systems because they regulate the airflow. But secondly, they also play a key role. So if you see dampers play a key role in HVAC system, right? Because they regulate airflow. But they also play a very key role in your firefighting. Why? Because they help in smoke control. So whenever there is smoke, suppose there's a fire at this location and your return air grill will take in all the smoke, and it has a very big chance that it will be taking it back to your HVAC system. So in that case, your dampers are automated with your building management system, and they shut down or they close down so that the transfer of smoke from one part to another part is prevented, and hence helps in larger firefighting solution. So let's check out the options. Option A, walls that regulate the airflow as per the air conditioned zone requirements. This seems to be correct. Let's check B, C, and D option also. Walls that regulate refrigerant flow as per air conditioned zone requirement. No. In refrigeration cycle, we have expansion walls that control refrigerant flow. Desiccants which used to absorb the moisture and dehumidify the air conditioned zone. No. Desiccant cooling is another broad type of cooling, in which generally, for example, the most primitive example is your air cooler, how it uses like basically in dry areas why an air cooler works, and in humid areas why does the air cooler not work. So desiccant cooling is something that you can look into. We also have desiccants in our medicine bottles which actually absorb the moisture and prevent the medicine from getting stale. So it is these silica packets which are there. So this is something you can additionally look into, but it is not nearly also related to HVAC dampers. Metal based sheets to absorb heat to cool the air conditioned zone. No. So the correct option is definitely option number A. Walls that regulate airflow as per air conditioned zone requirements. Let's move on to the next question. Question number 52. Again, a 1-mark MCQ question. This is from building materials, broadly from section 1.2, but the chapter is building materials, where we study different materials and the property, right from brick, stone, concrete, cement, sand, then paints, metals. So all of these various materials and the properties are covered in this chapter. This question is particularly from paints. Let's read the question. Dash increases the spreading quality of paints and helps to achieve desired consistency. Options are base, vehicle, paint dryer, and solvent. So if you see, what are the components essentially that helps in making the final, I would say, paint. So what is the role of base in that paint? Base provides a body and bulk to the paint. So basically it is a metal oxide which is there, which is your base of the paint. So it has nothing to do with spreading or consistency, as it is the bulk or the forming constituent of the paint. Your vehicle is your binder. So this is film forming component which holds the pigment. Pigment is something that gives color to your paint in suspension and helps in adhesion. So adhesion is extremely important because we have different components, different elements, different mixtures coming together. So there has to be some adhesion. There has to be coherence in the paint. So binder has the role of doing it. Paint dryer speeds up drying time. So again, nothing to do with spreading or consistency. Solvent or thinner adjusts viscosity, improves flow, increasing spreading quality, and achieves desired consistency. So this is the most correct answer. So if you see in option D, as per the provisional answer key that they had released, option D was marked to be correct and solvent would be the most appropriate answer. But now what has happened, because of the ambiguity of the statement, even if you see vehicle binder affects the flow and film formation, not essentially consistency, but definitely it will affect the flow and film formation. So giving vehicle and solvent together might have been a bit of ambiguous, created an ambiguous question. So now in our final answer key, this question has been awarded marks to all. That means all those candidates who appeared for the exam and attempted part B1 have been awarded full marks for this question, which is 1 mark, right? But in general, what is the takeaways that we have to consider from this question is the properties of a paint and what are the components, different elements that are used to make a paint. That would be very important, because if you see, even I think in GATE 2004, there was a question regarding paints, and such questions can always be jumbled in MCQs, in larger MSQs, and asked to you, right? Let's move on to the next question. The graph shows the typical test result of a property of a building material. Again, from building materials, so a very important topic. Identify the test and variables represented on the x and y axis from the given options. So they have given a curve which seems to go to a point which is your zenith point, and then it reduces. So we have to identify which is this graph, basically which property or which material is associated with this graph. So हम start कैसे करते हैं? If we see, to directly solve this answer, it would be D, which is bulking test of sand. But let's try and have look at the options also. So A, B, and C talk about tests on concrete, tests on strength of concrete. Especially these two tests are strength of concrete, where this is for your slump cone test, which is workability of concrete. Now in all these tests, even if you don't know the in-depth graphs or in-depth knowledge about these graphs, you like basic also for strength, with time your graph is generally linear in nature, okay? Because what happens, as the time progresses, concrete starts gaining its strength, okay? So it is not nearly also I would say a curve or a parabola in shape. Another test which would have been actually very tricky in this case would be finding yield stress and elongation in steel. So if you know, there is a typical graph that goes from this point, then it comes back and goes like this. So this could have been trickier option if I had mentioned steel's property of yield stress, but this is not given, so we don't have to worry. Now the correct option for this question would be D, which represents bulking test of sand, while where x-axis is moisture percentage and y-axis is increase in volume. So since we have understood the basics, now let's deep dive into the properties of the sand and graph. Okay, so what does this graph essentially show? First of all, we need to understand what is bulking of sand. Bulking of sand is a phenomena in which the volume of sand is increased when it starts absorbing moisture. Sand again can be classified as fine sand, coarse sand, medium grade sand. So if you see the graph which is present here, As the moisture content is added, the volume increases, where it reaches a saturation point in each of these cases, and then the volume starts decreasing. So, what is the property or what is the science behind it? So, if you have sand particles generally, they have voids in between, right? So, when water is added, when you have moisture, these particles will start forming films, water films around each other. Now, what happens? This water film will have high surface टेंशन और उसके वजह से क्या होगा सरफेस टेंशन ज्यादा है तो वो एक दूसरे को रिपेल करने लगेगा सो नेचुरली योर वॉल्यूम इंक्रीजेस इट बल्क्स राइट सो ग्राफ में हम देखेंगे इवन इन दिस ग्राफ योर वॉल्यूम इज इंक्रीजिंग नाउ टिल अ पॉइंट वेर इट रीचेस फुल सैचुरेशन मतलब इतना सैचुरेटेड है कि इफ आई एड मॉइस्चर टू इट अगेन this surface tension will start rupturing and the volume will be the water will be filled in the voids such that abhi kya hoga ki suppose this is our sand particles the water will start filling the voids which were present तो उसके वजह से क्या होगा your sand particles will start packing in because of the force और उसके वजह से volume will again start decreasing this happens the most bulking happens the most in fine graded sand because they have a higher surface area to volume ratio right and coarse graded mein consistency is also less and surface area to volume ratio is also low so this is seen lowest in coarse grading so these are important points regarding bulking of sand which can be again asked in gate exams because this is one of the very important properties of sand bulking of sand, then sieve test of sand. These two are one of the major tests and properties of sand. Let's move on to the next question. Question number 54. It is from B1.1 History and Contemporary Architecture and it is from the chapter Greek Architecture, Classical Greek Architecture. So a typical classical Greek temple with Doric order columns is illustrated in the figure. Identify the correct terms responding to P, Q and R. So they have given a typical Greek classical order facade and then you have to identify what is P, Q and R. So just to briefly go through all the elements starting from the ground level, if you see, you'll have your stylobate and stereobate, which is nothing but your steps and plinth. Okay, steps, plinth. So even in this figure, you can see the base, topmost base is called as stylobate, while these two are called as stereobate. Q. So again, then this would be your column, right? A column would also typically have a base, a shaft, and a capital. Okay, so if you see in Doric orders, we don't have a base, but in Ionic and Corinthian order, there is a base. Then this is the shaft, and then this is the capital. So in Corinthian order, we have acanthus leaf capitals. In Ionic order, we have volute leaf capitals. And a very important property that has been followed here is this tapering, or in some columns there is this bulging, which is called as entasis. Very important property which helps in visual correction of perspective when viewed. The third part, something which is like a slab-like structure or a beam-like structure which is resting on your column, is your entablature. This again has three parts, starting from the bottom, architrave, then a frieze which has a lot of ornamentation, a lot of stories which are conveyed, and your cornice. Above the cornice, you have your pediment, a triangular shape fascia, which is pediment, and this inside, the face of the pediment is called as tympanum. These decorative ornaments are called as acroterium. So these are the different terminologies associated with the classical Greek order. There are obviously more, as you can see. There is triglyph, then abacus, and a lot of other things also, which we'll definitely delve into depth when we do our history and architecture classes. But for this question, this much information is enough to for giving you the context of classical Greek architecture. Now let's start seeing the options. Option A, P is cella. No. Q is entablature. Yes. R is tympanum. No. A cella is centrally located room in Greek plan. So this option is wrong. In option B, we have P as tympanum, yes. Q as entablature, yes. And R as stylobate, yes. So this is our correct option. P is tympanum, yes. Q is acroterium, no. R is stylobate, yes. So due to this option, we'll discard this option. DP is cella. Again, cella, that there is nothing related to cella here. So naturally, this option is incorrect. So the correct option is B. The next question, question number 55, is from B1.2, Building Construction and Structural Systems. And it comes from a chapter, Building Construction, Deep Foundations. So this question is a very, I would say, knowledge based or information based tricky question. As in, you need to have knowledge of that particular pile system or pile foundation. You can't randomly guess. And upar se, this is a MSQ question. 1 mark MSQ question. So multiple options can be correct. So which of the following is or are examples of concrete cased pile? Options are Raymond pile, Swage pile, Vibro pile, and Simplex pile. So the correct answer for this is A and B, which is Raymond pile and Swage pile. So I'll briefly explain what these two piles are actually. A Raymond pile is basically a frictional pile, as you see. So again, in this pile, what happens? There is a steel shell which is present. It tapers down, and then it is cased, filled with concrete, and then the steel plug is removed. So it is a concrete cased pile. In swage pile, basically in swage pile happens in watertight conditions or marine conditions where your steel casing will be there, right? But it will be provided with a concrete plug. This concrete plug acts as a bulb or it swages out. So that's why the name is given as swage pile. And then again, this is filled with concrete and it is cased with concrete. So again, this is a concrete cased pile. Vibro pile, on the other hand, has nothing to do with concrete as such. There are Vibro stone compaction walls and compaction piles which are there. So you can check that out. So this is not the correct option. And simplex pile, again, what happens is in simplex pile there is concrete casing, but that is temporary in nature. That's why you cannot consider it as a permanently cased concrete pile. But again, I would say there's some sense of ambiguity still. But simplex pile would not be the correct answer. So the correct answer for this MSQ question is option A and option B, which is Raymond pile and Swage pile. So question number 56, which is from B1.3, Building Services and Sustainability. Chapter is Solar Architecture. So this is the last question for 1 mark questions. 1 mark questions, and this is a numeric answer type question, NAT question. Now, this chapter, Solar Architecture, is in harmony with Building Services and Sustainability. और वो आपको common part में section 3, which is your environmental planning and design. Usme bhi they can ask you. So in GATE 2022, there was a question in the common part. What do the concentric circles in a sun part diagram represent? So again, it can be asked in common part also. It can be asked in architecture part also. So this chapter is particularly very important. For a given location, the sun's position is 40 degrees altitude angle and 130 degrees azimuth angle north. The zenith angle of the sun in degree at that given location is dash. So basically, there are certain angles when we talk about solar architecture related to your sun's position. So if you see this illustration, there is north, east, south, and west. And related to sun's position, right? The planar angle, if you see in plan, the planar angle across directions is called as your azimuth angle. That's why a direction is necessary to be associated, like 130-degree north, right? Because you take in reference from north and then you'll go 130-degree. Altitude angle, altitude as we know is the height, right? Height. So this property is related to the vertical cross section, vertical cross section. So this is the altitude angle, and correspondingly, even in our BR syllabus, we are studied to design shape. So if you know you are designing, for example, this is your wall, this is your window. If you are designing a horizontal shade in section, whenever you are working with section like your chhajjas, overhangs, you use your altitude angle, right? This is your plane, this is your altitude angle. And whenever you're working, say with fins, suppose this is your window in plan and you have to design a shade here. So you will be working with the azimuth angle. So these two angles are given and the concept behind this is clear. Now what have they asked? They have actually asked zenith angle. So zenith angle is nothing but a complementary angle for altitude angle. It has nothing to do with azimuth angle. Azimuth angle is purely there just to confuse the students. But even if you don't know what zenith angle means, you can try and apply basic logic to the word zenith. So if you know zenith is nothing but a topmost or a high point, give high point or the highest point located from a user's reference frame. So if I'm standing here, this would be my zenith point for reference, a higher point, and another point is generally your lower point or lowest point, right? So zenith angle of the sun would be if this is the sun's location, say, right? This is the sun ray that is falling. So this is your altitude angle, and the angle between your incident ray and the zenith point or the vertical normal connecting the user frame to the zenith point is your zenith angle. So zenith angle is nothing but 90 degree minus altitude angle, which is 90 minus 40. So answer is 50. So the correct answer is in degrees. So the correct answer is 50 degrees. You don't have to write degrees there. It is mentioned in degrees. So the correct answer, you just have to type 50. You will be awarded full marks for this. So the next question, from this question onwards, we are starting with 2-mark questions. So we have total 9 2-mark questions, which is a mix of MCQ, MSQ and NAT questions. Question number 57. Match the items in group 1 to the corresponding items in group 2. It is from B1.2 and the chapter is generally all these hardware and miscellaneous items that we use. So the first is garnet. It should be garnet, aldrop, mortise, gusset, and you have to match the following to its association. Like, is it a plate? Is it a bolt? Is it a hinge? So let's start with that. Garnet is generally associated with hinge. So if you see, garnet will be definitely associated with hinge. It is a T hinge, which is generally used for door closing in wet areas or washrooms where you typically want the door to quickly close down. So this is garnet hinge. Second is aldrop. So aldrop is associated with bolts. Mortise, even if you don't exactly know what its function is, mortise and tenon joint we have studied in timber joineries. So definitely something to do with a piece going into a cavity or something interlocking. So lock is the inherent word that comes when we think about mortise. So mortise is definitely lock, as seen here in the image. And gusset, as we all know, it is a very common terminology that we use in steel trusses. Gusset will relate to plate. So the correct option would be P4Q3R1S5. The correct option would be A. P4Q3R1S5. Now again, this particular question has been repeated in previous year question papers. Like for example, in GATE 2016 question paper, if you check out, you will have aldrop and you'll have mortise. Then here there was a parliamentary hinge and I think it was panic bar, something like that. So these two elements have already been asked, and in GATE 2011 papers there were different types of plates. No, sorry. There was actually a question on what is not a component of steel truss. So in that there was gusset plate, which is obviously a component, and then there was fish plate. My point being, these three terminologies have already been asked in previous year questions. So even if you don't know garnet hinge and you have solved previous year questions, you can easily solve this question. So let's move on to the next question now. question number 58 is a match the following MCQ question from B1.1, and it is from a miscellaneous chapter which is famous architectural books and quotes, a very important chapter. These books, quotes, works often also come in common part. Sometimes they may, sometimes it comes in architecture part. So it is something that has to be studied for both common and architecture part. This is a link that I've compiled from Rethinking Future, so you can check this out. These are like 30 famous quotes that you should be aware of from famous architects. So the first is form follows function. Form follows function essentially talks about how we are moving away from unnecessary ornamentation, and the form purely is now responding to the function. This was given by Louis Sullivan, an American architect. He was a mentor for many modern architects, and I would say one of the most senior or the oldest architects who have given this quote to us. So this is an important aspect which has been asked in GATE many times. Less is more. Less is more, as the term says, again is from a modernistic approach where less ornamentation, less like you don't need to do gimmicks for your building or your building facade. So less is more, more minimal. So this was given by the German architect Mies van der Rohe, and again it is a very famous quote. The contradictory quote to this is less is more, given by Robert Venturi. So you can also study that. Then architecture should speak of its time and place, but yearn for timelessness. This is from Frank Gehry. There are no straight lines or sharp corners in nature. This has to be from Antoni Gaudi. We know Antoni Gaudi. He is a Spanish Catalan-based architect, and we all know Sagrada Familia, a very historic landmark which has recently completed. So we know he belongs from Art Nouveau style, and Art Nouveau is generally characterized by a lot of natural elements, free-flowing elements, organic elements. So there are no inspired from nature. So this, even if you don't know this, you can try and match all these options. So the correct option would be P2Q1. P2Q1. This option it has R4 yes and S3 yes. So C is the correct option. These type of quotes and famous architectural books have been asked multiple times in previous GATE papers. So you can definitely refer to PYQs, previous year questions, to strengthen your grip over the subject. Next question is from B1.3, Building Services and Sustainability, and it is typically from water supply. The section name is Pumps and Pistons. So this pumps ka chapter has also been asked. These questions on pumps have been asked in NET also, in which you have been given, you have to calculate the total head which is required, and in MCQs also. So in GATE 2023, there was a question based on centrifugal pumps, rotary pumps, reciprocating pumps. So this recently, not recently, but in like last 10 years, multiple questions have been asked on pumps and pistons. Sometimes students tend to like they don't give that much importance to these miscellaneous topics, but these are the topics which are more challenging, concept based, and can be asked in multiple questions. So let's look at the terms: suction lift, discharge lift, rotary pump, priming of pump. So everything is related to working of pump, components of pump, maintenance of a pump. So let's start with first suction lift and discharge lift. So if you see a typical working of pump, so you know if this is your water level, right? Your pump is placed on a plinth or on a base. So this distance between the center line of pump and the water level is called as the suction lift. So if you see the option, difference between the low water level and pump would be something which is appropriate to suction lift, because it is the lift is the distance, but it is the energy which is required to take in the water from your water tank. Discharge lift, discharge by its word, by the meaning, we can consider something which is discharging, or a level to which the water is being discharged. It's exactly what it means, from that particular line to your discharge level. So the first option, if you see difference between point of discharge and the pump, would be the correct option. Rotary pump is a type of displacement pump. So there are two types of pump: dynamic and displacement pumps. Again, a very broad topic to get into. But rotary pump The correct option would be 4. Water is carried upwards around the side of the casing and pushed through a discharge pipe. So this is how a rotary pump works. This has been asked in GATE 2023 questions also. So I would highly suggest to go through all these broad types and broad working of the pumps. And last is priming of pump. So priming of pump is basically a maintenance operation done for pumps. So if you see, your pump should not have entrapped air bubbles, right? Because it has liquid flowing through it. So those air bubbles should not be there, otherwise it will hamper or hinder the working of pump. तो क्या करते हैं जनरली, अगर आपने देखा होगा, even in your society or your house complex, your watchman or your मेंटेनेंस ऑपरेटर सुबह सुबह वो लोग क्या करते हैं, वो लोग पंप के उसमें वो थोड़ा बिस्लरी के उसमें से वो पानी डाल देते हैं, थोड़ा वाटर दे पुट इन दैट पंप सच दैट वो जो एंट्रैप्ड एयर होती है वो निकल जाती है. सो दिस इज एग्जैक्टली व्हाट ट्रिमिंग ऑफ पंप इज, which is filling pump casing with air to remove entrapped air. So this is a very common example which we see in our day-to-day life. The last option 5 is work done by a pump in raising the water is nothing but your head, which is not given. So the correct answer would be P3, P3 in option A and C, Q1, Q1, yes, R4, R4, and S2, yes. So this is the correct answer. Option number A. The next question, question number 60, is from B1.1, History and Contemporary Architecture. This time it is from Hindu temple architecture. So these are different temples that have been given, and we have to match their properties or the dynasties from which they have belonged. So let's have a look one by one. So P, Kailash Temple, Ellora. So Kailash Temple, Ellora is a very prime or famous example of rock cut temples we have in our Buddhist architecture, right? In Buddhist architecture, we have seen rock cut caves. Even if we see Ajanta, which Ajanta and Ellora both are located in Maharashtra. So Ajanta is famous for Buddhist Chaitya caves, while Ellora is famous for having Hindu, Jain, and Buddhist temples, caves, rock cut architecture. So Kailash temple particularly belongs to Rashtrakuta dynasty, and it has been carved out from a hill. So this was a hill, and it has been carved out. So the entire temple is made from top to bottom. So generally our typical construction process is from bottom to top. This has been carved out from top to bottom. So the most appropriate option for Kailash temple would be option number 4. Brahmanical rock cut architecture constructed by excavating out of hillside. Q, Shore Temple, Mamalapuram. Shore Temple, again, a very, I would say, unique and distinct and a very famous landmark which is there. This belongs to Pallava dynasty. Raj Sinha was the king, and there is very ornamental granite dressing. It is very famous for granite dressing. So the correct option here would be Pallava temple constructed of dressed stone. So Q is 3. All these temples are very interesting to learn about, and this entire portion has been covered in our history classes also. So it is this subject is particularly very interesting to learn if you start linking all these structures to geography. So if you know, Kailash temple Ellora is actually made up of basalt. So why is this basalt? Because the reserves of basalt are more in Maharashtra. So once you start linking geography to history, once you start linking construction technologies to history, the subject itself becomes very interesting, and you learn about different subjects in one go. So this approach is something you should definitely consider doing. Mahabodhi temple, Bodh Gaya. So Mahabodhi Bodh Gaya temple was actually rebuilt by Guptas in 5th or 6th century. 5th or 6th century. So the correct option would be temple from late Gupta period. Yes. And it is a very famous structure, which is one of the earliest structures which is built in brick. Then S is Brihadeshwara Temple, Tanjavur. Brihadeshwara is temple is an example of peak Hindu temple Dravidian architecture, which was in done by Chola dynasty, Rajaraja I, a very magnificent and mighty structure and a huge architectural feat. So this Brihadeshwara temple, one of the largest Chola temple, is the correct answer. So the first option, temple from Chandela culture, is not there. Chandela is basically refers to the dynasty in Madhya Pradesh. So all your Khajurao group of temples, Kandaria Mahadev temples, are all related to Chandela culture. So we know in our temple study we have studied Kalinga. Kalinga reflects to Odisha. Then we have Chandela, which refers to Madhya Pradesh, and then we have Solanki, which refers to Gujarat, Rajasthan region. So if Kandaria Mahadev was given as an option, it would match to Chandela structure, but option 1 is not present right now. Let's have a look at the options. P4, P4 and P4, yes. Q3, Q3, R2, yes, and S is 5. So option D is correct. Question number 61 is from structural systems and particularly from high-rise structural systems. So this particular chapter is also in conjunction or in common to common part A, section number 2. There are 4 buildings given to us, and we have to identify which of the following buildings are bundle tube have bundle tube structural system. Again, this question was previously very similar question was previously asked in Gate 21, where they had given a match the following type of question, where there were bundle tube structures, tube in tube structures, outrigger truss, belt truss, and diagrid structures. So understanding these high-rise structural systems and their examples is very important. Let's have a look. Sears Tower, Chicago. If you see Sears Tower, Chicago, built by SOM in Chicago, is one of the prime examples of bundle tube structural system. As you see, there are different building levels and cores which are projecting out. So if you see, all these are the different types of high-rise structural system, and steel bundle tube system corresponds to Sears Tower. So this is our option. The 42 Kolkata is the tallest tower in Kolkata city, but it is not a bundle tube structure. It is an RCC frame tube, a typical RCC frame tube, which has a central core, and then there are columns on the periphery. So this is not a bundle tube structural system. O14 tower, it has been given O16, but the correct name is O14 Towers, Dubai, is again famous for its exfoliated facade system or its skin rather than its structural system. So it is not the correct answer. D option is Bank of China Tower, Hong Kong by IMPI, and again, it is not a bundle tube structure. It might look as a bundle tube structure, but it is a famous example of space truss. So the only correct option, even though this is a MSQ, the only correct option is A, Sears Tower, Chicago. Let's move on to the next part, which is question number 62. Now from 62 to 65, we have all numeric answer type questions, NAT questions. So we'll be solving each and every question, and we'll also understand what is the concept behind that question. Okay, so let's start with 62nd question. 62nd question is from building, construction and structural systems, majorly from theory of structures, which the chapter is deflection of beams. A simply supported beam is under uniformly distributed load along the full span. The midspan deflection is measured as 24 mm. If the length and depth of the beam is doubled while keeping the other parameters unchanged, the midspan deflection is dash mm. Fairly simple question. The most important topic here is deflection of beams. So your deflection, your sagging or hogging, so it is related to your bending moment. So there is a differential equation, just to go into the concept. EI, Young's modulus, the moment of inertia, d2y by dx square is equals to m. So if you integrate it twice, you will get the slope. Integrate it once, you'll get the slope. If you integrate it twice, you'll get the deflection. So these are the inherent properties between bending moment, slope, and deflection. We'll dive deep into a separate video regarding deflection and behaviors of beam. But for now, this is a table which is very helpful for students. Generally, I would suggest you to actually make your own chart which has the support conditions for the beam. So it will include simply supported beam, it will include a cantilever beam, simply supported with a point load, a simply supported with a UDL, fixed beam, and continuous beams. And then you have to write down the shear force, the bending moment, the support reactions, the deflection, the slope, and in a very I would say logical and conceptual manner, where you are actually trying to find a relation between all these parameters. So that, and if you like kind of crack it, you can solve any question related to shear force, bending moment, and deflection bending theory of beams, which has been predominantly asked in GATE exam. So let's just solve this question. So for a simply supported with uniform load, that is example, this is the beam, right? If this is simply supported, say a hinge support here and a roller support, and it has a uniform distributed load of, say, load W. So the deflection delta is given by, if you see this formula, 5WL raised to 4 upon 384 EI. So W is your uniformly distributed load, L is your span, E is Young's modulus, and I is moment of inertia for that beam section. Now we are assuming the section is rectangular because it's not any particular shape is not given, and they are talking about depth, so we'll consider it to be rectangular. So now this can be written as 5W L raised to 4 upon 384 E, and the moment of inertia for the rectangular beam is BD cube by 12. Okay, so let this entire equation be 1. We know deflection is 24 mm because it is given to us. Now the second condition is, the case 2 condition is, length and depth of the beam is doubled while keeping other parameters unchanged. So length L nu is 2 into L, while your depth nu is 2 into D. Mind you, they have not mentioned anything regarding the breadth, so breadth will stay as it is. So our deflection mu will be 5W 2L raised to 4 upon 384 into E into B, because it's the same. D will become 2D cube by 12. Right? So can I write this as 5W L raised to 4? 2 raised to power 4 is 16 upon 384 BD cube by 12. 2 raised to the cube of 2 is 8. Right? So this entire equation 5W L raised to 4 by 384 BD cube by 12 is equation 1, which is your delta. So I can write this is 16 by 8 into delta. 16 by 8 is nothing but 2. 2 into delta. We have been given delta as 24 mm, can be written as 2 into 24, which is 48 mm. So the correct answer for this question is 48 because it is given in mm. Right? So for this you needed to have clarity regarding the deflection of beam, and you need to know the concept for the formula for deflection of beams. Let's move on to the next question now. Question number 63, B 1.2, building construction and structural systems, again from theory of structure, design of RCC structures. So this particular chapter was a very important chapter in our undergraduate BArch program, where you have, as per IS 456 2000, you have design of RCC slabs, RCC beams, RCC staircases, RCC columns, RCC foundations by 2 methods. You have working stress method and you have limit state method. In practice, generally we use limit state method only because it accounts for a lot of factors of safeties. So we'll be solving this question also by limit state method. IS code 456/2000 is a must read code for all architects and civil engineers. Especially the basics you should be aware of. Obviously, in depth it is not required for architects, but you should be aware of the terms, be aware of the information fundamentals. This question is I would say a kind of tricky and difficult question because nothing like this has been asked in the previous exams in architecture. But if you see, GATE Civil Engineering 2018 had a very similar question to this. So again, a question which is more interdisciplinary in nature has been asked. So let's try and solve this question. Now, if you see a rectangular RCC beam of section 250 mm with 400 mm, right? Sorry, 250 mm width and 400 mm effective depth is under a factored shear force of 120 kilonewton. So if you have your beam section, you have your 250 and you have your effective depth. Effective depth is basically what? So if this is your reinforcement, you consider the center of your reinforcement. You don't consider your clear cover. Right? So this has been given as 400 mm. So let me just write B is equals to 250 mm. D is equals to 400 mm. Your factored shear force, which is your V, is given as 120 kilonewtons. The design shear strength tau C of concrete is 0.35 Newton per mm square. Two-legged 8 mm diameter stirrups are used for the shear reinforcement. Assuming the yield stress of steel to be 450 Newton per mm square, the design spacing center to center of stirrups is dash mm. What are stirrups? Just to give a basic information. If this is a beam, right? A beam will definitely have its longitudinal and transverse reinforcement, the cage of reinforcement which is there. But addition to this, there are these lateral shear stirrups which are there, which prevent the beam from shear failure, and they are generally located close to each other in near the supports or near areas where the shear stresses are maximum. So if you see in a fixed beam, if you draw the diagram for a fixed beam, it is something like this, right? So you can see these two critical points where failure can occur have stirrups in larger concentration, and then they are gradually reduced. This is the concept behind stirrups. So let's come to the formula. So your spacing of stirrups, so your shear stirrups, I would say SV say, is equals to, as per limit state method, 0.87 Fy. Then area into T. This is area of your shear reinforcement. Then you will divide it by tau V minus tau C into B into D. So what is tau V and tau C? So tau C, as they have given, is 0.35 Newton per mm square, which is the design shear strength of concrete. So tau V is the design shear, which is shear force, which will be acting, shear stress, which will be acting on the beam totally for concrete as well as for the steel part. This is given by V upon B into D. Okay, so now let's solve this particular part. So we get tau V, we have B, we have D, we have all these values. So tau V can be written as 120 into 1000 because we want it in Newton per mm square. So 120 into 1000 divided by B, which is given as 250, and D, which is 400. Let me grab my calculator. Actually, we don't need a calculator. Cancel gets cancelled. 425 is 100, so it is 1.2 tau V. So we have this value. So we'll just substitute all the values here. So this formula can be simplified as 0.87 into Fy, which is given as 415, into ASV, which is your 2, because we have two-legged 8 mm diameter, right? So 8 into 8 into pi, so pi d square by 4 is the area, into d, which is effective depth, which is 400, will be entirely divided by tau v minus tau c, 1.2 minus 0.35 into 250 into 400. So we'll just simplify this. Let me just grab my calculator. So by simplifying, the value that we get is 36,296.705, by in the denominator we get 212.5. Dividing this, we'll get the answer to be 170.81 mm. So your spacing is coming out to be 170.81 mm. Now further, what we do is generally we have the minimum shear reinforcement. Minimum shear reinforcement is actually the minimum value of your calculation, which is 170.81. This is A. B is 0.75 into effective depth. So 0.75 into 400 would give us 300. And C is 300. So the minimum value is this. So the correct answer is around rounded off to nearest integer. So 170.81 can be written as 171 mm. So the answer key range, if you grab the answer key, is given around 160 to 180. So it's quite a broad range, and our answer is falling rightly in between it. So this is the correct answer. Obviously, since there are such intricate calculations involving pi and decimals, thoda if you consider decimal points, it will go above and beyond, but it should broadly lie in this range. There is also a working stress method through which we can solve this, where we also consider lever arm constant and all, but it is best to study limit state method. Okay, let's move on to the next question now. Okay, so question number 64 is a 2-mark NAT question from B 1.3, Building Services and Sustainability. Chapter is Lighting and Illumination. Lighting and Illumination and Acoustics are two chapters through which NAT questions are expected quite often and are very important chapters. You can see plethora of questions have been already asked in previous year question papers. So let's start with lighting and illumination. Before discussing this, I like to just go through some key concepts in lighting, which is key concepts. So there is obviously going to be a source, right, that will emit the light. एक source होगा जो light emit करेगा. तो जो source light emit कर रहा है उसको हम लोग luminous object कहते हैं. Luminous object. अभी वो source का luminous property रहेगा, right, कि वो कितना light emit कर रहा है. तो उसको हम क्या बोलते हैं? सोर्स का प्रॉपर्टी इज योर लुमिनस फ्लक्स. द यूनिट्स इज लुमेन. ये जो लुमिनस ऑब्जेक्ट है, राइट, जब वो लाइट रेज एक वर्किंग प्लेन पे डाल रहा है, सो द इंटेंसिटी थ्रू विच द लुमिनस ऑब्जेक्ट इज थ्रोइंग द लाइट एट वर्किंग प्लेन इज कॉल्ड एज लुमिनस इंटेंसिटी. This is given as I. This is termed as I, and the unit is candela. Okay, so the relationship between flux and lumen can be given as flux is equals to I into solid angle. Solid angle, which is given in steradians, is a 3-dimensional angle. For example, if this is a sphere, ठीक है, उसका ये point source है. Suppose ये एक angle पे, this is the 3-dimensional angle, if you can visualize this to be sphere, and this would be the surface area of the sphere on which the angle is being projected to, right? So if you see, this would not be flat, it would actually be if you see in 3D, it would be something like this. So your steradian angle, or your given by ohm, is nothing but your area upon r square. If this is r, then it can be given as r square. These are basics of lighting that I would like to discuss before going into the main property. And then the amount of light which is reaching the working plane. The amount of light which is reaching the working plane is called as illumination. Illumination. And the unit is lux. सो वीसी एनबीसी के हिसाब से इतना लक्स रिक्वायरमेंट है. वो लक्स रिक्वायरमेंट क्या है कि उतना लाइट सोर्स से गिरना चाहिए. एंड व्हेन वी नीड टू सिलेक्ट द लाइट फिक्सचर, वी अगेन कन्वर्ट इट टू लूमेंस. So lux is given as flux upon area. So it is kind of like lumens per meter square. Okay, so these are like the elementary properties in lighting. Let's now try and solve the question which is given here. A source of light located at point C. Again, we have to visualize this question. So a source of light is located at point C. Let this be the point. That is a source of light. Point A is 1.75 vertically below point C. Point A is 1.75 meters below C. Point B is situated horizontally 1 meter right of point A. Horizontally right of point A. 1 meter. If illumination level at point A due to light source is 300 lux, then illumination level at point B is what? So E at A, illumination at A is given as 300 lux. Okay, so now I have to find what is the illumination level at point B. As we have seen, illumination is your luminous flux upon area, but there is no this is only true when your light source is perpendicular to your working plane, right? Now if you see, there is an angle theta here, right? तो ऐसा है, अगर परपेंडिकुलर ऊपर है लाइट सोर्स, तो थीटा का वैल्यू क्या हो जाएगा? 0. Like if it is perpendicular, theta value will be 0. So the actual formula is f upon a into cos theta. This is known as Lambert's cosine law. So cos 0 is 1, so it is f by a. But if your working plane is from a distance where the light source is falling at an angle, then cos theta needs to be considered. This is one important thing. Now EA is equals to 300 lux. The property, the luminous intensity of the light source will be same for A and B as well, because it is the inherent property of your light source. It is falling from the light source. Lumens are the same, right? So let's just write this down. 300 is equals to flux upon area. Flux is nothing but your 4 pi, which is your solid angle. For a sphere, it is 4 pi because it is 4 pi r square upon r square into I, which is your intensity that we have to find, upon area, which is 4 pi r square, right? So this would be 4 pi gets cancelled, I upon 1.75 the whole square. So your I would nothing be equal to, let me just calculate it quickly, 300 into 1.75 into 1.75. Your I would be 918.75 candela. This is the same. Now from Pythagoras theorem, I can actually find R, right? R is the hypotenuse, so R square is 1.75 the whole square plus 1 square. So R is nothing but 1.75 the whole square plus 1 square. So R can be given as root of 4.0625, which is 2.015. So now you have R also. Why did we calculate R? Because in this formula, when we apply R for point source B, you will be requiring this hypotenuse end, right? Because iske through like if you see, if this is the inclination, वो sphere ऐसे generate होगा, right? Light source का. So this R we need to find. Now again from this theta we will have to find cos theta, because we have to find EB now. EB is nothing but F upon A into cos theta. Cos theta is for this angle. Cos theta is adjacent upon hypotenuse always. So for this angle, adjacent is 1.75 upon hypotenuse, which we just found 2.015. Let's just calculate this. 1.75 divided by 2.015. The value is 0.8684. Okay, so now illumination at point B will be F, which is your solid angle 4 pi into your intensity I, upon A, which is 4 pi r square. Now we'll be considering 2.015 the whole square into cos theta, that we found out to be 0.8684. 4 pi will get cancelled. I we know is 918.75. Let me just calculate it. This value is coming out approximately to be 196.51 lux. Since they have asked us to round off to the nearest integer, let's just round it off to 197 lux. Let's check the answer key. So answer key for this question has been given as 185 to 205. Again, a question, an answer which is quite lying in the center, so it is definitely correct. The answer is 197 in lux. So this is quite a lengthy problem, but if you have the basics of flux, intensity and illumination clear, it can be solved easily. You just have to be calm during the exam and avoid making silly mistakes like finding cos theta angle, or not finding hypotenuse r and then substituting a different value. These are the only silly mistakes which are possible during the exam. Always I would suggest use the GATE virtual calculator while practicing. It will help you, train you to give you real life conditions while solving numerical questions. Again, in general, all these notes will be provided on our WhatsApp and Telegram channel, so you can definitely join them. It is the link is given in our description in the video itself, so you can join the groups for further updates, further courses, and all these notes for free. So we have come to the final question of part B1. Again, a 2-mark NAT from acoustics chapter. Very important. Frequently, they have been asking questions from acoustics as well. In which acoustics, there are 2 major parts. One, finding sound intensity level, sound pressure level, or sound power level. And second is reverberation time and your Sabine method. So this is particularly asked from this section. Let's see what they've asked. There are 16 similar machines located radially and equally distant from a fixed sound receiver. While operating, each machine records 60 dB sound level at the receiver. So basically there's a receiver and there are various machines that are radially located. जब वो सिंगल ऑपरेट होता है एक मशीन, तो वो रिसीवर पे 60 dB देता है. One machine gives 60 dB at receiver. So they have asked, assuming 70 dB to be highest sound level allowed as per industrial sound pollution norms, the total number of machines allowed to operate simultaneously without violating the norms is dash. तो मतलब क्या बोल रहे हो लोग कि अगर मल्टीपल मशीन्स है, 16 में से मैं कितने मशीन्स चला सकता हूँ एक टाइम पे साइमल्टेनियसली, सच दैट ये सेंटर उस पे साउंड इंटेंसिटी लेवल इज ओनली 70 डेसिबल्स. So you have to find number of machines, n you have to find. There's a direct formula to this. So combined sound level intensity is given as 10 log to the base 10, which is your normal logarithmic with base 10, 10 raised to dB1 by 10 plus 10 raised to dB2 by 10 plus it's a series with the nth term being dB raised to dBn by 10. Right? where dB1, dB2 are your different sound sources. Say there are two sound sources of 6 and 10, right? Six emitting 6 and 10 decibels, so you'll be writing 6 by 10 and 10 by 10. But since luckily we have all the sound input being 60 dB, right? So we can simplify this. We have been given threshold, which is 70, 10 log 10, 10 raised to dB1 is 60 by 10 plus 10 raised to 60 by 10. Now I don't know what is this n. I don't know how many times do I have to repeat this. So can I write this simply as 10 log n into 10 raised to 6. 60 by 10 6 हो गया. n मतलब क्या? कितनी बार वो repeat हो रहा है? Basic multiplication. 3 plus 3 plus 3 is 9. 3 into 3 is 9. Same logic. Now this property I can also solve by logarithmic property. Log of m into n is your log m plus log n, right? Again, we do this in general aptitude. This is how your general aptitude knowledge and concept will help you in NAT. Can be written as 10 log to the base 10 n plus 10 log to the base 10 10 raised to 6, right? 10 log to the base, this can be written simply as log 10 to the base n raised to 10 plus 10 raised to 10, so it has to be 1. Log of base a to a is 1, so this is 6 into 10, which is 60, right? So now to just simplify, if we take 60 to that side, we'll get 10 is equals to log 10 n raised to 10. How can I write 10? 10 can be written as, if I have to just write log 10 base 10 to the power 10, right? I can write it as like this, and then log here will be 10 n raised to 10. So your log can be cancelled. You will get 10 raised to 10 is equals to n raised to 10. So n is equals to 10. So you can switch on 10 machines simultaneously such that 70 dB would be the maximum output. If you go to 11 machines, your 70 dB might increase to 71, 72, which would be against the norm. So this is the correct answer. With this, we finish part B1 of GATE 2025 Architecture and Planning, which is exclusively for architecture syllabus. In the next video, we'll be solving part B2, which will be the last video for this entire series. Hope you found it helpful and interesting to learn new concepts and actually analytically and conceptually think what the questions are and conceptually dive deep into them. If you found this video helpful, do share it with students and your friends who are keen in knowing about GATE and GATE architecture, or who are preparing for GATE architecture. Till then, I'll see you in the next video. Bye.